Codes here. Today we'll be discussing about recursion. What is recursion? Recursion is the ability of a function to call itself in the same function block. For instance, if you're told to print out the values of n from n itself to 0, how would you go about that? Most people will go about it in the normal way that people go about, which is just printing that value of n, and you go from n till n minus 1 till you get to n minus n, which is 0. So this is a good way to do it, I would say. But as a developer, you're looking for a better way to make the system more better, to make the code run faster, and to make the code more efficient. So that's where recursion comes into play. So the same question of printing from n to 0 can be achieved with recursion in a very simpler method. First, you declare a new method outside. That's my cap lock on. So it's printing out an integer, so the return type will be int, and I want to print values of n. Let's say values of n Yeah, let's give it a capital letter n. And it is going to accept an integer because you want to print from that n, because they did not specify the value. They just say you should print from n. N can be of any value. N can be of 50, can be of 30, it can be n can be 55, it can be 100, it can be 2. So that's why printing out with the system.out or print line method, it's not efficient. What if you are told to print out from 100 to 0? How would you do it? Would you write 100 lines of code? No. But recursion makes it more efficient in shorter time and with a shorter line of code. So it gets an integer of n. And first, in recursion, there's something we call post recursion and pre recursion. Post recursion is calling the recursive call after your print statement. That's pre recursion, sorry, calling the recursive call after your print statement. And post recursion is calling the recursive call before your print statement. So why is pre-recursion and post-recursion different? Pre-recursion is useful when you are going in a descending format. Why post-recursion is useful when you are going in an ascending format? Now we're going to look into it and we're going to see why both are both useful in their different aspects. So you check if what we're doing now is what we call pre-recursive, because we're printing from n to 0. So you check if n is not equal to 0, and that has to be constant. Unless n itself is 0, then you'll be able to print out 0. So if n is not equal to 0, you're going to print out the value of n. Why? Because you're starting from that n itself, and since n is not equal to 0, that easily gives you the access of knowing, oh, my function can continue because it's not going to break in the if statement. So you give it an else case to also check if n is equal to 0. If n is equal to 0, then you return 0 then. Why are you returning 0? Because the value of n is equal to 0. So you go on and you say, now I'm returning 0, but I want to print from 5 or from n to 0. So how do I go about it? You make sure you're updating your value of n. How? Because you've printed 5 already. You are going down, you are descending. So you are going to update your value of n, and then you reduce n by 1. Or you can say n is equal to n minus 1. And you go on and you return. Then you're going to call back the function itself again, and you put in the new value of n. So let's see what it does. Let's see the pre-recursive statement. Oh, we're not calling it in the main function yet. So you call system.out south. Where's south here? South, and you print values of, let's give it 10. So you see now I'm giving a higher value to show you why recursion is essential and why recursion is a very good thing to use, because it's more efficient and the time complexity is of a form of linear, because it breaks the size of the function bit by bit, size by size. As it's removing one, it's breaking it down to 1, it's breaking it down to 1. So, and it's breaking it down in n number of times. So that's why it's linear. And the space complexity is also linear because it takes a stack of n number of times, and this time it makes the code more efficient and it makes it more faster. So let's check it out. So it prints out from 10 itself, which is n, to 0. So this is what we call pre-recursive, because it's printing out the function before the recursive statement itself. If you look at it from here, it prints out the function of system.out.println n. So now you now ask me, what is post-recursive? Post-recursive is using the recursive stack before the print statement, using a recursive call before the print statement. Now let's give it an let's use an example of that. Just assume you want to print from 0 to 5. How do you do that? How do you print from 0 to 5? It's basically easy. Printing from 0 to 5 is basically easy. So you create your method int, because it's the keyword is int, and because it's going to return an integer as a value. So print n, print value of k. Let's call this k, because we don't want it to clash with the other name of the other function. So now you're going to check if k is not equal to 0. Then if k is not equal to 0, you print. No, it's funny, right? You kind of wonder, but we say we are printing from 0 upward. Yes, we are still going to do that. We are going to achieve that. But first, the integer given cannot be 0, because if it's 0, it will return itself back. So like the first thing we did there, you check, k, if k is not equal to 0, it's not equal to 0, right? Yep. If k is not equal to 0, then you call the function. Now we are calling the function here. So that will be south. You're calling back the function print values of kn. That will be k minus 1. Just watch. And then you check else. You return 0. And then you come here to return your k. And now let's break this down. It says if k is not equal to 0, system out.print, you're printing the values of kn, which is the next one. So you wonder, so it's coming down from 5, 4, 3, 2, 1 to 0, but it's not yet printing it out, right? Because it's calling the function again. And when it gets to 0, when it breaks in that statement, it starts returning k. Because here you are still under the if statement here. When it breaks with the value of 0, it goes back again to the recursive statement it hasn't printed out, and it starts printing out the values. Then you get it from 0, then you get 1. Once you printed out 0, because 0 is the base case, once you get to that 0 statement and you pull out of the if statement, you print out 0, then you go back to the previous recursive statement and you say, wow, so there's 1 here before. Then you print out the 1, then you go to 2, then you go to 3, then you go to 4, then you go to 5. So that's post recursive. I'm so sorry. So let's run it. Let's change this and let's see. Yep. And let's call 10. And let's see if it's going to print from 0 to 10. You see, it prints from 0 itself to 10. So most times when people talk about recursion, people go ahead with Fibonacci series, and people go with binary search. But sometimes it's actually easier for people to learn by using easy methods, easy way to teach. So that's why I came up with printing from 0 to n, from n to 0. That gives a very vivid explanation of recursion and a very beginner level understanding of the word recursion. Thank you very much. Make sure to like, to share, and to subscribe. Drone Codes out.